Section 5.4 is point-slope form. I can write and graph linear equations using point-slope form. Big ideas for this section. The slope and y-intercept of a line can be used to write and graph an equation of the line. One form for writing the equation of the line is the point-slope form. And any two equations for the same line are equivalent. Take note on page 315, please make sure you add this to your note card if you haven't. Point-slope form of linear equation here. The point-slope form of an equation of a non-vertical line with slope m and through a point x1, y1 is y minus y1 equals m times x minus x1. If we look here, guys, our framework is this part. That doesn't change. The point that we plug in, our x1 and our y1, go into y1 and x1. And our slope goes in here. So again, this right here comes from our point, and our x and our y without the little ones stay there. So a line passes through -3, 6 and has a slope of -5. What is the equation of the line? Our framework is y minus y1 equals m times x minus x1. Now we can plug in what we know. We know our x is -3, so I plug in minus -3 gives me a plus. Y is 6, so I plug that in here. Again, y and x. My slope is -5, so the -5 I plug in here. And I leave it just like that. Now, go ahead and pause and try this one, please. Okay, again, our framework is y minus our y value equals m times x minus our x value. X goes inside with x, y goes with y, and it's minus a -4. Slope goes in for m. So we end up with just y plus 4 equals 2/3 times x minus 8. And that is point-slope form and what we're looking for. To graph an equation in point-slope form, the great thing about slope-intercept and point-slope form is that they're very descriptive. They give you the information that you can get from the equation. So when we were dealing with slope-intercept form the past couple days, we could get our slope and our intercept. In point-slope form, we can pull a point and a slope. So for our point, remember our equation is y minus our y value equals m times x minus our x value. So the numbers that are plugged in here, 1, 2, and 2/3, come from our point. 2, 1 is our point, and our slope is 2/3. So instead of graphing this from an intercept like we did yesterday, we are going to graph from a point. So at the point 2, 1, I put a dot. Now I use my slope here, and I go up 2/3. We can also go in the other direction, down 2, back 3 if we want. And that lets us have the 3 points that we'd like, or more, to be able to continue and make sure we're right. Then we will connect our dots here with a straight edge. Something kind of like this. And arrows. Okay, so again, we're going to pick out our point, 2, 1, plot the point, and then use our slope from there. Go ahead, pause here, and give it a try. Okay, remember here that our framework is y minus our y value equals our slope times x minus our x value. So when we plug in a 7 here, it's y minus a negative 7. So it's plus 7 to get there, which means my y value is negative 7. We have a 4 that goes in this blank, so it's just a positive 4. 4 and the negative 7 are our point. The negative 4/5 goes in for our slope. So our slope is going to be negative 4/5. We start at our point 4, negative 7. And from there we use our slope. Down 4 over 5. Down 4 over 5, which is approximately here, or again we can go backwards, so we can go up 4, back 5. Up 4, back 5. Again, it doesn't matter which way the negative goes, whether it's with the 4 or the 5. So by going up 4 and back 5, we're using a negative 5 instead of a negative 4. Now, connect your dots with a straight edge and draw them in. Something kind of like that. Got a little bit off there. I don't have a line feature on the version that I'm using right now. So line should look something kind of like that. Example 3 is using 2 points to write an equation. What is an equation of the line on the graph on the top of page 317? And I put it here as well. It's kind of big for this screen. But we can pick out some information here. We can find our slope. That slope is by finding our rise and run. So I can go up 1, 2, 3, 4, 5, 6, 7. So I went up 7 and over 1, 2, 3. Now, we need to find point-slope form. So in order to do that, we need a slope, which we have, and a point. It does not matter which point we pick. We're going to pick this one here. Negative 2, negative 3. So our equation is y minus our y value equals m times x minus our x value. That's our framework. That's the part that stays the same every time. Now, my x goes inside with my x, minus a negative gives me a plus. My y goes outside with my y, minus a negative gives me a plus. And my slope goes in for m. So y plus 3 equals 7 over 3, x plus 2. Now, go ahead and pause it and try to come up with the equation for the same graph using the other point. So using this value here. Okay, so we're still going to use point-slope form. We still have the same slope. We're going to use the point 1, 4 instead. So, in my framework, the x goes with the x, my y value goes with my y value, and my slope still goes here. So it doesn't matter which point we choose, you guys, because these are going to be equivalent. If we were to reduce them down and solve for y, put them in slope-intercept form, we'd have the exact same intercept. So as long as we substitute our points in the same, we're going to get the same slope-intercept form. They are equivalent equations. Here's one that's not in the book, but something I wanted to show you. We have 2 points, guys. We don't have a graph, but we can still use point-slope form to find this the same way we did before. So I have points, but in order to find point-slope form, I need a slope. So we'll find that first. Remember, slope is rise over run, which is the change in our y's over the change in our x's. Remember, rise is y's, run in x's. So it doesn't matter which one we pick first as long as we're consistent. So if I use 1 minus -3, remember minus a negative gives me a plus, I have got to use 2 first. So 2 minus a -4. 1 plus 3 is 4, over 2 plus 4 is 6. I can reduce that, guys. 2 go into both of those. That's 2 over 3. And this is my m value. Now, point slope form, we need just that. We need a point and a slope. Have my slope. We can use either point. It does not matter. So y minus y equals m times x minus x. If we use 2, 1, I put my 2 with my x, my 1 with my y, and put in my slope. We also could have used -4, -3. Set up your framework again. X goes inside with your x, minus a negative gives us a plus, and minus a negative gives us a plus. When we plug our y in with our y, slope is still 2/3. So either one of those would have worked. Example 4 here, using a table to write an equation. The table on the bottom of page 317 shows the altitude of a hot air balloon during its linear descent. What equation in slope-intercept form gives the balloon's altitude at any time? What do the slope and y-intercept represent? Okay, so here's our table. This is a linear descent, which means our rate of change is always the same. So we need to figure out what that rate of change is. To put it in slope-intercept form, we need to have slope, regardless of which form we're going to start with. So we can pick any 2 points. I'm going to use these 2, but again, it does not matter. We take our y over our x's, our change in y's over our change in x's. So 640 minus 590 over the change in x's. Since I use 640 first, I have to use 10 first, minus 30. Since I use this one first, I've got to use this one first. 50 over -20. That reduces to -5 over 2. And that is my slope. So, I know it says to put it in slope-intercept form, guys, but we only have points and slope. So we can start with point-slope form and then solve for y to get slope-intercept form. I'm going to use this point, but we can do it out of any points. So y minus my y value equals slope x minus my x value. In order to solve for y here, I need to distribute first. I took -5/2 times x and -5/2 times 10. Now, add 640 to get y by itself. I also can rewrite this with -5 over 2 is -2.5x because we're looking for an application kind of thing, and we're trying to figure out what do the slope and the y-intercept represent. Slope is -2.5, and we're talking about altitude in meters and seconds. So every 1 second, the altitude drops 2.5 meters. And the 665 is our y-intercept, means that we started at 665 meters. I'm going to stop here because I'm going to run out of time, and I will finish on another video.